Hey everybody, this is Dan. This is a week 8 update video for statistics, spring 2014. We are getting ready for a test week. The test over chapters 4, 5, and 6 needs to be completed by this Friday, March 7th. And just wanted to get you caught up on everything. I know we've had a lot of problems in chapters 4, 5, and 6 here with the discussions. I think most people have figured out how to get the applets to run. And if you need a little more help with that, it's in the FAQ discussion board area here. There's some helps on how to get to run on Windows and Mac and other things. So yeah, it's about how to get the Java to work. I am not counting anybody late that didn't get chapter 4 done. Chapter 5 discussion board is due Monday at midnight. That'd be March 3rd. If you're gonna have problems getting that done, at least submit something again to say that I'm having troubles, and please contact me if you haven't got that figured out. And then chapter 6 is going to be due on Thursday, March 6th at 11:59 p.m. The online homework for chapters 4, 5, and 6 will also follow those due dates, so be sure to get all of those done. We've been doing a lot of them in the face-to-face class as well. And if I go, for instance, into chapter 5 content here, this is what's due tomorrow. We've got down here, I've got some class notes, and that's got some worked out solutions from some of your homework. While I'm here on chapter 5, many people had submitted discussion board things for this, and I'm not sure what exactly happened. Some people, I think, they weren't actually running the simulation, maybe, I'm not sure, but you need to, for instance, launch this binomial distribution and answer the questions. And what we're doing here is simulating having 5 children, or 1,000 families having 5 children, and the distribution of those, of boys and girls, based on what they have. So we're supposed to change the probability to 0.4, and then jack it up to do like 100, and then do like 1,000 families. Let's do 100, and we'll hit simulate. And so you should be reporting, you know, oops, I don't want n equals 10, I want n equals 5. I want 5 children. There we go. Okay, so in this simulation we have 9 families that had 0 boys, 25 families that had 1 boy, 36 families. And then take a look at that distribution and compare it to the theoretical one. You know, theoretically, how many families should have no boys or 5 boys? That's kind of what it's asking you there. So if I go back to the discussion board and you answer, you know, based on your simulation, how many couples had 0, report those. Make sure it's at 40%. How does this compare to the simulated? You know, what did you observe? How does it compare to the simulated? Now check your results for the average. So you can say then do it for 1,000 couples and see how many boys you actually had compared to, theoretically you should have, you know, 2 out of 5 is the theory. So if you had 1,000 couples, which would be 5,000 children, there should be 2,000 boys. See how your simulation compares to that. And then this is like extra, but if you just took n times p, that gives you the mean. So n is like, you know, 5 times p is 0.4. There you go. You should get average 2 boys per family. And if you actually calculate out the theoretical probability for each of these, it matches 2. So for part 4 there. So just a little hint on that. Again, run the simulation, get your own numbers, and compare that to the theoretical. I did post a video here on how to use StatCrunch to find the mean and standard deviation of a probability distribution. That will speed up your homework if you're struggling with how to do those. And if you ever have questions on, if you seem to be doing a lot of work, again, there's probably a technological way to do this, and I usually post those videos here. So make sure you're kind of going through this flow here when you're doing your work. So I'm going to go back out here to chapters 4, 5, and 6 again. Textbook and review materials, getting ready for this test. We've got the old tests here from previous semesters. I would encourage you to go through those. And it's got the formula sheets and tables, but I also have them out here. Just the test 2 formula sheet and the z table is all you're going to need, and that will be provided with your test. So the Um, and I've left off the basic ones, how to find compound probabilities, just basic and or situations. Um, the only I've put the ones here that you're going to need a little help on, like conditional, if there's an overlap, how to do that if they're non-mutually exclusive. Remember, the expected value is the same as the mean, and that is just the sum of each occurrence times the probability of each occurrence. The binomial probability formula. And then the new thing for chapter 6, which you should have done last week, is the central limit theorem. Notice it's the only difference is instead of analyzing one piece of data, we're looking at the group mean. And regardless, if you went through those applets, regardless of the distribution you're pulling from, if you take repeated samples of the means from each of those samples and plot those, you'll get a normal distribution, which is why we can use that z-score formula there. So that's really powerful. Again, I would strongly encourage you to go in the test, watch the solutions videos. Like here's the ones from last fall. Here's the test, the solutions, and the solutions video. Really encourage you to go over that. We will be having our weekly online office hour tomorrow night at 9 p.m. I'm sure there'll be lots of things about test review involved with that, and I would encourage you to be there for that. I will try to record part of that. Again, if you ever want to get in on those, it'll be in your weekly email here, but also you can always find the links right here. Right for here it is for the 3rd of March. There's the link. If you click on that, that takes you to the online office hour at 9 p.m. So I know there's work for everybody. But so it's a big week, lots of work to be done. I've caught up on all the grading for the discussions. If I did not get 10 out of 10, you might want to revisit those, look at the comments. You can keep redoing those to get full credit. And so you're going to want to get chapters 5 done by Monday night, chapter 6 done by Thursday night, take the test by Friday. Your proctors will get those emailed to them tomorrow morning. On Monday morning, and so yeah, that's about it. Hope everything's been going well for the homework. I will be posting even more of those under course content, chapters 4, 5, and 6. We're going to do some more of those in class on Monday, and so you'll see a link here for the chapter 6. I'm going to add some notes here on Monday over some homework problems and things, so that will be added tomorrow. For this chapter 6 discussion, it's called All Men Are Dogs. It's not a very, I guess it's kind of weird. It's this bad pickup line this guy uses and how much it works and stuff like that, I guess. So, but what we're doing here is taking random samples from a population and checking how the samples look. And the big thing is we're comparing here the standard deviation of the population and the standard deviation of these repeated samples that come from it, and the comparison of those two. And then it leads us into the sigma over the square root of n. So you're supposed to kind of see the comparison between, if I take the average of a group of 5 versus the population, how does that look? And yeah, so you're just kind of confirming that this works for the central limit theorem. But yeah, do those, and I'll try to keep up with the grading on those throughout the week. And there's lots of good applets here. I would strongly encourage, obviously we use one here in the discussion on sampling distributions, this last one. There's also a good one here about the central limit theorem, and the good videos in those as well. So kind of a long video this week, I'm sorry, but hopefully it's been useful, and I will be sending you a message. And contact me if you have any questions, email or phone, and good luck on your second exam.